Today, we're going to talk about the TwinCAT event logger. The TwinCAT 3 event logger is responsible for transmitting events. An event is a message or an alarm. This technology allows the machine to report issues to the operator and provides the programmer several functionalities to develop an intelligent alarm management system. In this episode, we will cover the definition of events, messages, and alarms. We will code a message example and see how we can use the createEX and send methods. Besides that, I will show you 2 ways to integrate your messages with your Windows application in case you're not using backup HMI. And finally, show how to parametrize an event. We will also work on an alarm example and explore how to trigger and manipulate its state transitions. So let's get started. The event class organizes the events, but an event by itself isn't really useful for us. Messages and alarms are. It turns out that these types are derived from events, and they inherit some important elements from the event class, like an event class global unique identifier, an event ID, text, source, and JSON attribute. The most important difference between messages and alarms is that messages are stateless, while alarms are not. An alarm state can be raised or not raised. In addition, a confirmation can be demanded. In other words, we have 2 possible confirmation states, confirmed or reset, and waiting for confirmation. If a confirmation takes place via confirm, the state of the alarm is set to confirmed. If a confirmation takes place via clear, the alarm is set to reset. The architecture of TwinCAT 3 event logger is centralized and the messages are stored in cache. Backup HMI integrates very nicely with the event logger, but this will be another video for another day. So let's start by creating a new project. And then adding a new PLC project. Once I have my new PLC project, I can add TC event logger to the references and create my event class. So you're going to navigate to System, type System, Event Classes, New. Here we can define our new event class. So we're going to call it event class, and it comes with 1 event. We're going to change it to event 1 and add a display text to it. I can also set the severity. It's going to be a warning. And I'm going to add a second event. This is my event number 2. Same thing, I'm going to add a text and a severity level. This one's going to be critical. Once I have it, I need to rebuild my solution. This will update my TS_proj file and include these events and this event class in the project. So now if I navigate to my folder and open up the TS_proj file, I can see that the event class and the events I created are now listed here. So now that we have an event class, we can start coding. We will start by declaring the variables that we need for this messaging example. We're going to need a boolean to trigger event 1, a boolean to trigger event 2, and a boolean to trigger the send method. We also need an instance of fbtcmessage. This if statement evaluates the state of init event 1. If this boolean is true, then we create a new message and reset the value of the variable. The same thing is applicable for the second event. Finally, we need a listener for bsend. If this bit is true, then we send the message. So now if I trigger my event 1 and also trigger the bsend bit, I can check my message by navigating to TwinCAT Windows, TwinCAT Logged Events, and hitting the Update button. Note that the source name is relative to where your FB message function block was declared. So in my case, I've done it in the main. Now I'm going to show you two ways to access and integrate these messages. Even if you are planning to use backup HMI in your project, it may be interesting for you to learn about these options. They are trickier, but they give you a lot of freedom. In this next example, I'm using Backup Template for a C# integration that uses their COM API. I'm adding a subroutine to this template that will add messages to a SQLite database. The template is very convenient because it already has an onMessage sent sub checking for new messages. All I'm doing here is calling my sub upon TwinCAT sending a new message. I'm passing as parameters the database path and file name, as well as the message parameters that I'd like to save to it. I'll leave the link for the backup C# template on the description, and as always, you can find the examples in our repo. Another way to do it is to use the Windows Event Logger. You need to change your registry to be able to do so. And go to HKey Local Machine, Software. WoW 6432 Node, Backoff, TwinCAT 3, Event Logger, Windows Event Logger. Here, you're going to need to change your values so they reflect what I have, 003. Now navigate to Control Panel, System and Security, Administrative Tools, Event Viewer. You can add a custom view to see your TwinCAT events. Select all event levels by source and search for TwinCAT Event Logger. I'm not going to create it here because I already have one, but as you can see, all my messages are also posted here. And the convenience of this approach is that you can use PowerShell to export these values. Now, let's see how to parametrize a message. First, declare your parameters. They don't need to be strings, as we'll see in a second. We need to change the definition of the event and include placeholders for these parameters. Then, call the method addString through the IP arguments interface pointer, passing your parameters. Build your solution and download it to the controller. Now, your messages can be customized. Let's talk about alarms. Similarly to the message example, I will declare 3 booleans. One to trigger the alarm, one to confirm the alarm, and one to be toggled when I have an alarm. This last one is only to demonstrate that we can monitor the state of an alarm and do something with it. I also need an FB alarm instance, but we will need to create this function block first. So add a new POU and make sure that it inherits or extends from FB TC alarm. Our inputs are an event entry, an event trigger, a confirmation bit. We also need a couple of auxiliary Boolean variables. So, when we call this function block, an alarm is created through the createEX method from fbtcalarm, and bitInit is reset to false. Then the function block evaluates if the alarm trigger is active, and if the alarm hasn't been confirmed. If so, it will be raised. Next, we check if the alarm trigger is still active. If not, the alarm is cleared. The only thing left to do is to check if it was confirmed. Note that I have used the reserved word super to refer to my parent class. Now I can call my alarm, check in what state it currently is, and make a decision based on that. I forgot to initialize bitInit in my function block. Let's rebuild the project and activate. By forcing these control bits, I can change the state of my alarm, as you can see it from the error list menu. One last thing to note is that this CSharp template already has subroutines to manage alarms as well. I hope you find this video useful, but if you still need more help with your project, Beyond Kinematics offers consulting services in PLC and HMI development, robot programming, machine vision, and data acquisition. We also have a really cool pipeline for PLC offline development. We create a realistic digital twin of your machine and hook it up to a PLC. This way we can develop your application independently from having the hardware on hand. Don't hesitate to reach out, the contact info is in the description. Thank you.